Hi everybody. This week we are going to cover Chapter 4, which is Language Essentials. This chapter basically goes through some of the relatively newer concepts that exist in the C# language. Most of these features were released with .NET 4 or C# language version 4. Um, so these are very essential components to developing an ASP.NET MVC application, and this chapter focuses on covering those concepts in fairly good detail, trying to give you at least kind of get your feet wet on these ideas. So we're going to start out by just covering these items this week, and we're going to go in somewhat of an unconventional approach. What we're actually going to use instead of using an MVC application is I'm going to go ahead and just use a standard console application. And this application is here to kind of allow us to focus on what we're looking at in terms of language features. We're not worrying so much about MVC, but we're wanting to focus on these language features. So what I've done is I've set up a new application, a new project, console application, and I've named it 14SS Week 3 MVC. So this is our console app for this course for this week. And what I'm going to do is I'm going to walk through this and try to just kind of hit the highlights of what the chapter discusses and just kind of fill in some blanks around what are they talking about, how does this work, and why are these features important in the language. So the first feature I want to talk about is the idea of automatically implemented properties. Now, if you're familiar with C# as a language, you know about, in really any object-oriented language, you have this idea of private fields or private variables, and then you have public properties or getters and setters. The syntax in C# is here's a private variable, so private int underscore product ID. The underscore is a convention that I personally use for private variables. It just helps to distinguish them from public variables. And then we have this public getter and setter property, which is public int product ID, and it does a get returning the private product ID, and then the set takes the value, which is a keyword, and the value is the item being passed into the property, and it's taking that value and storing it inside of product ID. So what's here are fully declared properties with private fields. The automatically implemented properties, however, follow a similar convention, but it's a lot shorter syntax. So what I'm going to do real fast is I'm going to split my screen here, and I want to be able to look at just this segment of code, and then I'm going to scroll down to my other region, and I'm going to do an auto-implemented version of product ID. Now, to do that, the full syntax would be public int product ID, and then I'm going to do my curly brackets, and then I'm just going to do get semicolon set. And what this does is it creates a public property, product ID, with a getter and a setter. But you notice that there is no private field or private variable called underscore product ID or just product ID. The reason for this is that at compile time, the compiler will actually take this, what I kind of call a property shorthand, or the automatically implemented property, and it says, okay, this is a get and a set. So it does the work for us of actually declaring a private variable and then expanding the get set into this fully implemented syntax. Now, this is not a full replacement for any get or set scenario, but these very simple ones where you just want to declare a private field and then have a public property, the shorthand is definitely a benefit, and it makes your work a lot faster and a lot easier. Now, if there's business logic that needs to be considered, such as product IDs cannot be negative numbers. You must declare or define a product ID. Those types of pieces of logic, those are not able to be managed or handled using these automatically implemented properties. So you would still have to extend or do a full implementation of the property, but for real simple things where you just want to stub out a property and your implementation isn't something that you want to worry about immediately, these shorthands or these automatically implemented properties are really great. So if we go through, we can actually comment out all of the fully implemented ones, and we'll replace them with the automatically implemented. And then what we'll do is we'll just replace the full implementations with the automatic. Now there is what are called code snippets that exist in Visual Studio. So you can type prop for property. If you do a double tab, it'll give you kind of a template or a blueprint or a snippet that you can follow. So the int keyword is now kind of highlighted in blue and it's selected, so we can just type over that and replace it with string, hit tab, tab again, it'll bring us into the property name and we can call this name. Hitting enter completes the property. I can hit enter, do prop again, double tab, string, tab, tab, description, enter, prop, tab, tab. This will be a decimal, tab, tab, price, enter, enter, prop, tab, tab, string, tab, tab, category, enter, and we're done. So this is a lot easier to read. It's a lot more concise than what you would see typically in a full implementation. We only took up probably about, well, for every property it's one line of code, so we have 5 properties, so 5 lines of code versus this one being almost 30 lines. So these automatically implemented properties are a definite benefit as you're going through the process of creating your models, creating your classes for your project, and getting those types of pieces of information kind of sifted or sorted out. The next piece of the chapter I want to kind of cover is this idea of inline product initialization. The next section I want to talk about is the inline product initialization. This idea is that if you declare or define a product, and maybe you're declaring a new variable or a new instance of a product or any class, you would want to go through and initialize the properties of that class. Traditionally what you would do is you would have to do some sort of logic, and I'm going to jump into my static void main here. You would say product, and we'll say new product equals new product. And then from there we would say new product product ID equals 1 semicolon, new product name equals cheese semicolon, new product description equals stinky cheese, new product dot price equals $19.99. So that would be the full kind of declaration for a product, and we'd go through that process. The inline product implementation or initialization is similar, but it's a little more condensed. So the way we would do this instead is we would say product P equals new product, and then instead of doing open close parentheses semicolon, we're going to do curly brackets and a semicolon, and then inside of these curly brackets we have access to just the properties of this product. So from here we can say product ID equals 2, and then instead of a semicolon we would do a comma, and then we can say name equals apple, description equals red delicious, category equals fruit, and the price equals 99 cents. Now these different sets of lines work and function in fundamentally the same way. What's happening here in lines 20 through 26 is that a new product is being initialized inside of the p variable, and then the compiler takes care of doing p.productID, p.name, p.description, p.category, and p.price. Visually and readably, this is more concise because you don't have to repeat the variable name, and everything is kind of packaged as a unit, so any modifications or changes that are made within the curly brackets only affect the p variable. And if you needed to rename the variable p, you would make one change here and you wouldn't have to touch each line of the initialization process. So this is an inline initialization. You do not have to break this into separate lines as I've done. You can do all of this on a single line and it'll all work perfectly fine. But when you have a long list of properties, sometimes it's easier just to put them all on separate lines just for clarity and readability. Similarly, we can actually declare collections of properties using very similar notation. So if we wanted to do a list, or I'm sorry, an array of products, so maybe this will be our product collection. Traditionally, we would have to do new product array with 10 items. And then we do product collection 0 equals, and now we can use our inline initialization, new product, and then we would say product ID equals 1, name equals, and we'll just use cheese again, semicolon, and then we do product collection 1 equals new product, product ID equals 2, and name equals apple. And that would be how we would initialize all 10 positions of that collection. What we can do alternatively is we can use the same kind of inline syntax by simply saying product array, and we'll call this a prod collection this time, equals new product, and we'll do square brackets, and then we will do curly brackets with a new line. And then inside of the curly brackets, we can use our inline initialization. So we can, if we just cut and paste from here, we'll say product 1. Instead of doing a semicolon, again, we use a comma. And product 2. And we now have prod collection initialize position 0 and 1 with these two line items. So this syntax, again, is kind of an inline initialization, which can come in very handy when you're working to package up model data that you're sending to your view. If you're expecting a collection of items or you're needing to work with a particular collection or type of items, this facilitates that type of functionality for you. So it's a really great, not a hack, but it's a very simple way to kind of evaluate trying to initialize variables, trying to get code to be as concise and easy to read as possible, and being able to initialize collections and pieces of data that you need without having to type additional characters and repeat yourself over and over again. The next thing that I want to talk about is a concept known as an extension method. Extension methods you will see throughout the .NET framework as of version 4, and you'll see them especially within the context of ASP.NET MVC when you're working with the HTML helpers, building your views, and working with any sort of data collection system, whether that's ADO.NET, which is under the system.data namespace, or working with the entity framework, which is underneath the system.data.entity framework namespace. These extension methods work in tandem with a concept called link, and I'll talk about link a little bit later in this lecture. So what we'll start off by doing is I'm going to keep my collection of products here, and I'm going to add a couple of prices. So we'll make our cheese $4.99, and then here we'll make the price of our apple 99 cents. You may be wondering what the M at the end of the number means the M is a signifier to the compiler to say that this number, 499, should be treated as a decimal versus a float. By default, if you just put the number 499 in your code, you'll get a conversion exception where it's saying that it does not understand if that number is a float or if it's a double, and it doesn't know how to handle it, and then it'll recommend that you use the M suffix to create a literal type. So whether you use uppercase or lowercase m, it really does not matter, but that M signifies that this number should be stored in memory as a double. Alright, so I have my two products. What I'm going to create now is I'm going to create another class, which I actually have already created, called a shopping cart. So this class acts or functions as a shopping cart. And it has a collection of items, which I've used my shorthand declaration or property autocomplete to do. So we have a list of product called items, and it has a public get and a private set. That private set means that I cannot say items equals new list of products. It only can be initialized from within this class. So my constructor says items equals new list of products, and that's how items gets initialized. So when I create a new instance of shopping cart, this constructor gets run and it initializes items for me. So I'll go ahead and do shopping cart equals new shopping cart. So I now have a new cart. And I'll just go ahead and I'm just going to add a small series of items. So I'll say cart.items.add, and I'll take them from the products collection. So I'll add a 0 positioned item, which is cheese. I'll add 3 cheeses, and then I'll do another cart.items.add, and we'll do prod collection 1, which is the apple, and I'll add 2 apples. So 3 cheese, 2 apples. And these are apples. Alright. Now what I want to do is I want to be able to sum up or get a total price for the cart. Now traditionally what we would do is we would actually have our cart, and we would probably create some sort of function out to the side. Let's see, this will be a double, I'm sorry, not a double, decimal. And we will say get total, and we'll pass in the shopping cart. And then we'd have to go through the process of doing a for each loop. So we'd say for each product p in cart dot items, and we would need a decimal of total price and set that equal to 0. And then we would say the total price is a plus equals of the product price. So looping through the cart of items, we would grab the price of each item and add it to the total price, and then we would at the end return total price. So if we wanted to get the total, we would call get total, and we would pass into it our cart, and that would give us our total. This works perfectly fine. The catch is, if this application becomes more complex or more sophisticated, we would have to then declare the get total method in every place in the application. So that becomes a little bit of a hindrance. The second option is that we could take this method, get total, and we could move it into our shopping cart class. That also works great, assuming that we have access to actually manipulate or change the class. But let's say that the shopping cart and the products classes were not part of this project. They were actually compiled and they were given to us as a class library or a DLL file. So we don't have the liberty to go in and actually modify the code. And that's okay. What we can do instead is we can create what are called extension methods. And an extension method allows you to take a class that you as the developer don't own or have the source code to, and you can add methods or functions onto that class dynamically by extending them. these functions do not get compiled into the class itself. They actually live in a separate static class, and that there's a special syntax that's used to link or bind the two together. So if we want to make getTotal an extension method, what we would need to do is we would want to first start by creating a new class. And what I like to do is I like to put all my extensions in their own folder. So I'm going to create a folder for extensions, and then I'm going to add a new class. And I'm going to make these my shopping cart extensions. Now, extension methods have to be defined inside of a static class, so I'm going to make this a public static class called shopping cart extensions, and then every extension method itself actually has to be a static method. So we'll do public static, and this will return a decimal, and then we'll call this getTotal, and then the parameters that this method will take will be a shopping cart. Now here's where the syntax specificness kind of comes into play. Our first parameter is the type that we want to extend. So our first parameter here is shopping cart, but to make this an extension, we actually put the keyword this in front of that first parameter. So by saying this shopping cart, this tells the compiler and tells Visual Studio that this method is now an extension method. And what this looks like to the computer and to the compiler is that we will be able to say in front or at the end of any cart variable, any shopping cart variable, we can say .getTotal. So if we flip back to program, we're going to update our using statement so that we're using the 14SS extensions namespace. And we can come over here to our line 28 and we'll redeclare this as decimal price equals cart.getTotal. And you'll notice here in our IntelliSense that the icon is slightly different. It's still a cube, signifying this as a method, but it also has this little arrow that points down, which is identifying this as an extension. And you'll also notice to the right there that the pop-up description in parentheses says this is an extension that returns a decimal and that it is shoppingcart.getTotal. So the compiler looks at it as being an extension or a part of the shopping cart class, but in fact, it's a completely independent implementation that does not live inside of the shopping cart class. So we can call it just like this with no parameters, and that will return us the total price of the cart for this particular instance of a cart. So this getTotal will basically receive this cart as the first parameter, and then it will go through the logic, and we'll just steal the logic out of here, of summing up the total price of the cart and returning it. So this is a great way to take methods, or I'm sorry, to take classes that you don't have access to their source code, and you can extend them and provide them with additional functionality. So if you have things where you need to build totals, or you need to go fetch data using some mechanism, and you're needing to use information as it pertains to that cart, or maybe that product, or that user, you can build these extension methods, and it allows you to dynamically grow and extend a class without actually having to own that class. So this is a great little feature and enhancement to Visual Studio. Along with that is this idea of being able to do what are called lambda expressions. And these lambda expressions allow you to declare and pass functions into other functions or methods. These lambda expressions are basically short little functions that do really simple logic, and they're able to be declared in one line. So you don't have to declare a full function, you just kind of declare the guts of a function, and from that the application is able to do what it needs to do. Now, the lambda expression syntax is a little awkward at first, but once you understand what it's doing, it actually gets a lot easier to understand. So what I'm going to do is I want to go back to my shopping cart extension, and I'm going to add another parameter here, and I'm going to add a function parameter, and my function is going to take in a product, and it's going to return a boolean, and we'll call this our product selector. So product selector is actually a method variable, or a delegate. And what we're able to do here is we can say, inside of our for each loop, we can say if product selector p equals true. So if this function is called and it returns a boolean of true, then we'll include that product in the total price. If it returns false, then we will not include it in the total price. Now you may be thinking, okay, well, where does product selector come from? How do we get that? Well, from our program.cs, we would actually need to, in a traditional sense, declare a function. And that function would be something like public bool filter products product p, and we would say if p.category equals fruit, return true, else return false. And we'll go ahead and add a category here. And we'll set this category to cheese, dairy. Alright. Double equals here. And then we would say in here, we would say filter products. And this needs to be a static for scope. So we're passing in this function of saying if p.category equals fruit, return true, else return false. So now I'm going to convert this function into a lambda expression. I'm going to do it kind of step by step. So the first thing we need to recognize before we get into the actual lambda expression itself is that this logic can be greatly simplified. Something that some people don't always consider is that this if statement is looking for a boolean in between these parentheses. So what happens is that p.category equals fruit gets evaluated, and you could basically say bool is fruit equals p.category equals fruit. So what will happen is the computer will evaluate p.category equals fruit. It'll decide if it's true or false, and it will take that true or false and put it inside of is fruit, and then we can say if is fruit, return true or return false. Well, if is fruit is true, it'll return true. If is fruit is false, it'll return false. So what we could do here is we could remove this completely and just say return is fruit. Because if is fruit is true, we're going to be returning true, and if is fruit is false, we'll be returning false. So we can just return the true or false from is fruit. Now, let's go one step further and simplify this again. If this evaluates to true, is fruit will be true, and then we're returning the true that's inside of is fruit. If this evaluates to false, is fruit will be false, and then we're returning the false from is fruit. So what we can do is instead of declaring is fruit, we can simply say return p.category equals fruit. So if p.category is fruit, then it will return true, because this evaluates to true. If p.category does not equal fruit, it will evaluate to a false, and then we will return false. So you see how we kind of condensed all of that into one line of code, where before we had it set up as 5-6 lines of code. So that consolidation gives us the perfect scenario for creating a lambda expression. Now, what does a lambda expression look like? Lambda expressions, and I'm going to comment this out, and we'll replace filter products with a lambda expression. So what a lambda expression looks like is it looks like a function. I'll just do it right here, where the function has a parameter, and then instead of doing curly brackets, you would do a equal sign and a greater than symbol, or an arrow, and then on the right side of the arrow you would put your logic that you want to be evaluated and returned. So in our case, we would want p.category equals fruit. So this is a perfectly valid lambda expression. This lambda expression can then be dropped in for a function pointer. So by dropping this in here, this function, product p, which is the parameter, as shown here on line 34, is passed in, so that becomes p, and then p.category equals fruit. This is then evaluated, and a boolean is returned. We can infer that p is a product because the function that we're writing this lambda expression for is expecting a product in and a boolean out. And because it's explicit in the function definition, we can make it implicit in our lambda expression. By making it implicit, we actually don't have to say that p is a product. We can simply say p, which is our parameter, and then we can say p.category, and it knows that p is a product because the parameter coming into the function, which I'll show you again in the shopping cart extension, this is the parameter in, a product, and then the return value is a boolean. So it knows that the value coming in, p, is a product, and it knows that whatever is evaluated on the right side of the arrow should evaluate to a boolean. So this expression of p, where p.category equals fruit, is a perfectly valid lambda expression and is the perfect equivalent to the filter products method. Now we can trim out additional parentheses, and we can actually simplify this even more by eliminating the parentheses, and we now simply have p, where p.categories equals fruit. I want to pull this out just so you can see it standing on its own. So this is a lambda expression. So by doing this, we can create these really short functions that allow us to do things such as filtering and restricting or selecting code or pieces of data from a collection. And there's also ideas around being able to pass in parameters, which we'll see in greater detail once we get into a lot of the MVC work. But this idea of a lambda expression basically means that this is the parameter, and the parameter is inferred by the method that's calling it. And then we can now say p is a product. So with p, we have access to all of its methods and properties. So we have access to the category, the description, the name, the price, and the product ID. In this case, we're saying if p.category equals fruit, return true. So then inside of our shopping cart extension, this product selector references the lambda expression here on line 30. So when our code actually gets to line 18 inside of the shopping cart extension and says product selector p, this p is the same p that then gets evaluated inside of that lambda expression. When we get near the end of this lecture, I'm going to go ahead and actually run this code, and you can see how those pieces interact with one another. So that evaluation occurs. If it's true, total price gets the price of that product added. If it is not true, then it falls through and continues on to its next method. So at this point, we have covered Automatically implementing properties, inline product initialization, inline collection initialization, extension methods, and lambda expressions.